Welcome! In this video, I'm going to teach you about OpenAI APIs and key OpenAI concepts such as tokens, probabilities, and language models. In this video, you're going to get hands-on experience by creating a practical solution where we write an email assistant browser extension that uses OpenAI Completions API to write and improve emails. This video is actually a part of a bigger course, Complete OpenAI Integration, where I cover everything regarding OpenAI and how to integrate it in your software products. Throughout the course, I provide detailed explanations of all concepts, mechanisms, tools, and terminology. To help you retain the information better, each section includes hands-on exercises for you to complete. I cover all of the API endpoints that are available at the time of this recording, and I will make sure to keep the course updated if there are any changes. The API includes mechanisms for completion, edits, moderations, images, image edits, image variations, embeddings, fine-tuning, and other utility APIs. By the end of this course, you will have a clear understanding of OpenAI APIs and the ability to integrate them into almost any project. Whether you are a beginner or an experienced developer, this course is designed to help you take your skills to the next level. I hope you're ready, so let's get started. AI is becoming increasingly prevalent in the world, and it's enhancing various industries such as healthcare, finance, transportation, and many more. AI algorithms boast powerful abilities to analyze vast amounts of data, make predictions, and perform other tasks that have been nearly impossible to do so far. As software developers, it's important for us to understand the capabilities of AI and how we can utilize it in our projects. Luckily, we don't have to do it from scratch. OpenAI has state-of-the-art language models trained on colossal datasets which they expose through RESTful APIs. For example, OpenAI's GPT-3 API can be used for natural language processing tasks such as text summarization, text classification, translation, or even generating code, while the dall-e API can be used for image and video manipulation tasks. By integrating these APIs into our projects, we can take advantage of the power of AI without having to spend time and resources on developing and training our own models. This allows us to focus on building our projects while still getting the best of AI capabilities. AI is a rapidly growing field, and most organizations don't have the resources to keep up with the latest developments, so it's much more affordable for them to use services like OpenAI to integrate AI features into their products. Because of this, there is a huge demand for developers who can integrate these features into their products. This course is not intended for absolute beginners. I expect you to have some experience building front-end web applications and you know how to send HTTP requests to remote endpoints. We will be using JavaScript for developing the browser extension, so I hope you have some experience with those as well. You don't have to build a browser extension and you can just play with these APIs with curl or Postman, but I suggest you to try and apply them to some project. You can follow along with the course on Windows, Mac, or Linux. Personally, I will be using KDE Neon, which is a popular Linux distribution, and I will be using Visual Studio Code as my code editor. OpenAI has trained cutting-edge language models that are very good at understanding and generating text. Their APIs provide access to these models, and they can be used to solve virtually any language processing task. Some of the fundamental features of OpenAI APIs are content generation, summarization, classification, categorization and sentiment analysis, data extraction, and translation. Before writing our own code, we're going to take a look at some examples that OpenAI have provided on their API documentation website. First, we will take a look at the completions endpoint examples, which is the core of the API and provides a simple interface that's extremely flexible and powerful. You basically give it a prompt and the API will return a text completion that attempts to match whatever instructions or context you gave it. You can think of it as a very advanced autocomplete, where the language model processes your text prompt and tries to predict what's most likely to come next. Let's play with these examples that OpenAI has provided. We can click on the play button here to submit the prompt. So that generates a horse name. Let's change it and ask it to generate a cat name. And as we can see, we get a name befitting a cat. We can make our prompts more specific, so let's say we want a Japanese-like name for a black cat. Suggest one Japanese-like name for a black cat. Nice. Now let's ask it for a white cat name. Excellent. Next are some more complex prompt examples. In this one, we're asking for 3 names for a horse that is a superhero. I'm just going to change that to a cat. Run it. And we got some results. Now, the OpenAI team is saying that these names are pretty generic. Personally, I think they're okay, but they think it could be better, so let's take them up on that offer. What they're trying to teach us here is that it's helpful to both show and tell the model what we want. So adding examples to our prompts can help communicate patterns and nuances. Look at the following prompt. First, they defined the question and then they provided examples of what kind of answer is expected. So if we run this, we get what's considered to be a better result. So if we compare that to the previously generated superhero cat names, these will look more similar to examples we've provided. Now, prompt phrasing isn't the only way to affect completions. OpenAI provides a few parameters we can adjust to affect completions. One of the most important settings is called temperature. You've probably noticed that if we submit previous prompts multiple times, we get identical responses almost every time. This is because the temperature parameter was set to 0. Let's try submitting the previous prompt with the temperature parameter set to 1. Now, if we submit this prompt multiple times, we most certainly get a different completion every time. So, what does this temperature parameter do? Well, the model predicts which text is most likely to follow the text preceding it. The temperature parameter essentially lets you control how confident the model should be when making these predictions. Lowering the temperature means it will take fewer risks and will only pick completions with the highest probability of being correct. Raising the temperature will result in more diverse completions because the model will consider picking completions with less probability of being correct. For example, for a pet name generator, it would be better to have a higher temperature because you would want to generate a lot of name ideas. So the name of temperature 0.6 or greater would be a good choice. The OpenAI team provides a sample JavaScript application that we can download and run locally on our machine to try out their completions API. First, we need to download the source code from GitHub. If you don't know how to use Git, you can just download the source code archived in a zip file. I'm going to clone the repository to my machine. So git clone and paste the link they've provided. Let's change into the sample project directory. Now I'm going to open VS Code in the context of this directory. Next, we need to add our API key. First, we need to create the .env file and store the API key there. Let's just copy the .env example file as the env file. cp.env.example into .env. Now we need to open our OpenAI profile. If you don't have a profile, you can register one for free. You can also sign in using your existing Google or Microsoft accounts. Click on your account badge and click the View API Keys item. Now generate a new secret key. If you want to reuse this key later, make sure to save it somewhere safe, like a password manager, because OpenAI will not reveal the full API key again in this web interface. Paste the key in the .env file. If you've integrated applications with third-party APIs before, you probably know this, but make sure to never leak these keys to anyone. These are your private keys that allow you to access the API. Nobody except for you should know about them. That being said, in this example, we're putting the key in a JavaScript application that runs in the browser because it's convenient that way. But you should never ever do this in real projects, because anyone who downloads your JavaScript code in the browser will be able to use this API key, which means someone could use your key for malicious purposes or just spend your OpenAI credits. So for real applications, make sure to place API keys on the backend applications where nobody can see them except for you. Okay, with that small rant out of the way, let's run our sample application. First, we need to install all the dependencies, so open the terminal and run npm I. This will install all the dependencies this project needs to run. Now we can run the project. npm run dev. Open the link. And we can see the pet name generator application. Let's type in cat and send. And there are the suggestions. Alright, let's see what we've got here. This is a web application built in next.js. In the pages directory, we have index.js, which is the code of the page we're seeing in the browser. So this is a pretty standard React application that uses the modern React hook mechanisms. So we have this onSubmit function, which is triggered whenever the HTML form is submitted. The function simply sends an HTTP request to our local server using the browser fetch API. The endpoint is specified in the API directory. Here we have the OpenAI library imports. We're reading the API key from the .env file, and then we're defining the server endpoint, which is called from the front-end part. I know I ranted before how you shouldn't keep keys on the front end, and in this case we are actually keeping them on the back-end part, but still it's very important that you understand that. You should never ever keep your keys on the front end where everyone can see them. Next, we check if the API keys are loaded, then we validate the request, after which we're calling the OpenAI completion API. So we're passing it an object containing the language model we want to use, the prompt, and the temperature, after which we await, extract, and return the response. This is the function that generates our prompt, so it takes the animal name we've entered and it embeds it inside a bigger prompt. That's just about everything regarding this sample application. This example demonstrates a small part of the possibilities we have with OpenAI. The completion endpoint is flexible enough to virtually solve any language processing task, including content generation, summarization, semantic search, topic tagging, sentiment analysis, and so on. One limitation to keep in mind is that for most models, a single API request can only process up to 2048 tokens, which is roughly 1500 words. That's between the prompt and the completion. OpenAI models process text by breaking it into smaller units called tokens. Tokens can be words, chunks of words, or single characters. You can visualize tokens by using the OpenAI Tokenizer tool. Let's visualize the following sentence. I have two cats, Kuroneko and Shironeko. Kuro is black and Shiro is white. This tool visualizes generated tokens from the text. As a rule of thumb, one token generally corresponds to about 4 characters of text for common English text. we can open up the OpenAI Playground where we can play with various parameters and see how it affects the completions. For example, let me write, I have two cats, Kuroneko and Shironeko. And we'll stop there. Now I'm going to show the probabilities, the full spectrum, submit, and we can see how the completions are coming in. We can click on words and characters to see the probabilities of possible completions. Let's delete the completion text and submit again. Okay, so as we can see, we're getting similar responses. Notice that most of the completion text is highlighted in green or yellow. That means that only the completions with the highest probability were picked. Let's increase the temperature to 1 to see what happens. Notice that now there is much more text highlighted in orange and red, meaning that completions with less probability were picked. In summary, the prompt text is converted into tokens which are then passed to Completion API, which uses the selected language model to generate completions for the prompt, while taking into consideration the temperature and other parameters we've set. The model I've used so far was Text DaVinci 3, which at the time of this recording is the latest and most capable model in the GPT-3 series. If you open the model dropdown, you will notice a bunch of other models. Each one of these has its advantages and disadvantages. The Text DaVinci 3 model is a good all-rounder, meaning you can use it for virtually any task you want. Its strengths are complex intent, cause and effect, creative generation, search, and summarization. After that, we have Text Curie 1, which is less capable than Text DaVinci 3, but it's still pretty good. Its strengths are language translation, complex classification, sentiment, and summarization. Let's try it out. So as we can see, the completions were generated significantly faster, but they're somewhat less expressive, although still pretty good. Let's lower the temperature to 0 and try again. Yeah, I would say this is pretty good. Now let's try Text Babbage 1. This model is significantly simpler and faster, but it's also far less capable than DaVinci and Curie. Its strengths are moderate classification tasks and semantic searching. Let me just set the temperature to 0.6. Run it. And we still get pretty decent results here. Lastly, let's try Text Ada 1. Its strengths are parsing text, simple classification, address correction, and keywords. Okay, so that's a very basic completion without much substance to it. And if you run it a few more times, you will notice there are significant inconsistencies in the completions. These have been the models from the GPT-3 family. There are also models from the Codex family which specializes in code completion and generation tasks. We can open the Codex JavaScript sandbox and explore examples there. So the playground already offers several examples that we can copy and paste. So let's try some of them out. This first one is very simple and it only needs to display an image of a cat. So let me copy and paste that. Run it. And it generated code for displaying an image of a cat. Very nice. Let's ask it to make the image fit to 70% of the screen size. There we go. Now, let's ask it for something more complicated. Make a ball bounce around the screen and change color on every bounce. Okay, now that's great. If you wish to follow this course using a different programming language, you can visit this page to find a list of community libraries that currently exist for OpenAI. Note that OpenAI does not verify the correctness or security of these libraries, so make sure to take a good look at those projects before you decide to use them. In this course, we will be using the official OpenAI libraries available for JavaScript and Python. Calling OpenAI API endpoints is not difficult, and you don't necessarily need a library, but they do help you to get started faster, and they also have some nice features like retry logic and more graceful error handling. In case you're curious, here are the Visual Studio Code extensions I am using. Auto Rename Tag, which automatically renames both sides of a tag pair. Babel JavaScript provides additional syntax highlighting for modern JavaScript versions, React JSX, Flow, and GraphQL. Change Case, which allows me to quickly change between various case notations. Darkula Theme, which closely resembles the Darkula theme from JetBrains IDEs. IntelliCode provides additional code completion features. IntelliJ IDEA key bindings, which brings many keyboard shortcuts from IntelliJ. Material Icon Theme replaces and adds various icons for different file names. And Prettier, which is an opinionated code formatter. Here is my settings JSON file. The font I'm using is Fira Code with ligatures enabled. And whenever you see a keyboard shortcut pop up in the bottom, that's from the built-in VS Code screencast feature. You can enable it when presenting so that your audience can see all the keys and shortcuts you're pressing. Let's start off by creating the project structure. I'm going to go into my home directory, /projects, and create a new directory, email_assistant, cd email assistant. To get started with our extension, I will be using a boilerplate to get me started faster. This is a popular Chrome extension boilerplate. I'm going to download the zip archive, extract it, and copy everything into our project directory. Now I'm going to open this directory in VS Code. This extension template uses React, and it's suggested in the README file that you should have Node.js 18 or greater. Personally, I've tested this on Node.js 16 and it worked fine. However, I suggest you to update to version 18 to avoid any issues if you can. You can check the version by running this command in your terminal, node-v. We need to change the project information in the package.json file. Name is email assistant. Version, I'm going to set it to 0.0.1. Description will say sample extension that uses OpenAI to help write better emails. You can set the repository URL to be empty. Next, we need to update name and description parameters in the manifest.json file. Name will be email assistant. The description will be the same as previously. Also, make sure to delete the Chrome URL overrides property because we don't want to override new tabs. And I will replace the project icons. Okay, we've updated the project metadata. Now let's install the dependencies. npm I. Run the project in development mode. npm start. Let's open the extension management menu. Enable developer mode. Load unpacked extension. Navigate to the build directory of our project. Select that. Okay, the extension seems to have been loaded. Let's open it. Nice. Now, I don't want to just work with plain old HTML elements. I want the project to look pretty, so we're going to install Bootstrap. npm install Bootstrap at version 5.2.3. Now we need to import it in our index.jsx file. Go to Source, Pages, Pop-up. Open the index.jsx file. Import the styles. Since Bootstrap is located in the node_modules directory, we need to go up by 3 levels. Also go into index.css and delete the unnecessary font family properties. Add some padding to the body. Padding 14 pixels by 6 pixels. Then go to popup.css and delete everything. Now let's open popup.jsx. I'm going to import useState and useEffect from React. I will also declare the API key property with useState. For the HTML markup, we are going to have a div element with the class name of container. Then inside we have a form. Inside the form we have a div with a class name of mb-3. Next we have a label, HTML for API key, class name form-label, API key. Let's add an input field. Type text, class name form-control. ID is going to be API key, name is also API key. Placeholder is OpenAI API key. Value is assigned the API key property, and on change, we're going to say E goes to set API key, and we give it e.target.value. And after that, we say div with the ID of API key help, class name form-text, and we specify a useful message on how to obtain the OpenAI API key. Let's run the project in development mode and try it out. Open the extension pop-up. There is our input field, nicely styled with Bootstrap. Let's try entering some value. Close the pop-up and open it up again. The value wasn't persisted after we closed the pop-up. That's because this pop-up is like a small HTML page that is rendered every time we open it. So after it's closed, all the changes are lost. Here we somehow need to persist our API key so that it doesn't have to be inserted every time the extension is opened. Generally, when we need to persist data after the page is closed, we would use local storage. However, for our use case, there is a little challenge. We cannot use the classical local storage API here because whatever we store into it, we won't be able to access it inside content scripts. Content scripts are special scripts that allow the extension to interact with the web page. However, they are somewhat isolated and they have their own local storage, so we cannot read from the local storage that we used here. To get around this issue, we can use the Chrome local storage, which is a similar API to local storage, but it's asynchronous. However, the most important feature of Chrome local storage is that we can read it from inside our content scripts. In order to use Chrome local storage, we need to add permissions for it inside the manifest.json file. So we simply say permissions, and we give it an array with one string, storage. Now let's make sure that the API key gets written into Chrome local storage every time it's changed. So we're going to say chrome.storage.local.set, and we declare an object with a property OpenAI API key and give it e.target.value. Use effect. We declare an arrow function chrome.storage.local.get, and we pass it the array with property names. In this case, we just have OpenAI API key. Then we declare an arrow function, and we use object destructuring on its parameter to extract the OpenAI API key property. And we simply set the API key with the OpenAI API key from Chrome local storage. So every time the value of this input field changes, we're going to update the API key property, but we're also going to persist the new value into Chrome local storage. So on each change of the API key input field, we're updating the Chrome local storage entry. So if I open the extension pop-up and type in some text, it should be reloaded into the input field the next time I open the pop-up. There we go. If at any point you're stuck or you've messed up your code, you can download it from my GitHub repository. The link is in the description. Now that we've set up our project, we're going to create what's known as a content script. The content script is the script that is executed for selected websites, in this case Gmail. We want to select the DOM element where the user types the email and add a button for triggering the completion. Unfortunately, the Webpack hot reload doesn't work for content scripts because Webpack dev server cannot establish a socket connection to the domain of the content script. So to refresh content script changes in the browser, you have to build the React project using the npm run build command. After which you need to go to your extensions and reload the email assistant extension so that it picks up the changes. It's a bit unfortunate, but there is no other way around this. Now, we want to add a button to the Gmail form for composing email. To do that, we need to select the form DOM element and add a button to it. Because Gmail is loaded in multiple phases, doing this is going to be a little tricky, because our content script code will execute once and immediately finish. Let me show you what I mean. Let's open the content scripts file, which is inside the source/pages/content directory. I'm going to delete the existing code. Let's select the email composition form. First, we need to find it in the DOM by using the inspect element tool in our browser. Use the element selector and select the form. Okay, so it's a div element which unfortunately seems to have minified attribute values. Also, I'm not sure if these class names and IDs are changed every time Gmail is updated. Luckily, there is one unique attribute on the email form g_editable. Now that we know this, we can access this DOM element from our content scripts. Const Gmail form is assigned document.querySelector, and we say div with the attribute g_editable. And I'm going to log it to see if it was selected properly. All right, let's build a project. Reload the extension. Reload the page. Well, it printed out null, which is the problem I mentioned before. The content scripts executed before the page was fully loaded. To get around this, we can create an interval where we select the email form element every second. So this way, even if the content scripts execute before the page is loaded, they will keep trying to select the element. Set interval, and I declare an arrow function with an interval of 1 second. And I just move the code for selecting the form element inside the body of the arrow function. Again, build the project, reload the extension, reload the page. There we go. We are successfully selecting the email composition form. However, there is yet another small issue we need to fix. In Gmail, you can open multiple composition forms, but our code only selects one. To get around this, we will select all DOM elements with the G-editable attribute. So we're simply going to change our code to say document.querySelectorAll, and this will select all div elements with the G-editable attribute. Again, build the project, reload the extension, reload the page. And now we're selecting all the email composition forms. Very nice. Our next task is to add a button to this form. I'm going to create a new function that attaches our button to the provided DOM node. Function attach assistant button with the parameter node. And I'm going to say node.insertAdjacentHTML before begin, which means we want to insert this element before the other elements. And we define a multi-line string. We say div with the ID email-assistant-button with the class assistant button. The SVG element was obtained at pictogrammars.com. Search for the creation icon. Click on it. You can copy it as an SVG element or download it in various formats. I have assigned the assistant-btn-inner class to the SVG element, and the fill attribute has been set to a near black color. So we're attaching a div with an SVG that will represent the email assistant action. I'm going to add the assistant button CSS classes to content.styles.css. So first I'm going to define the assistant btn class. So we want to change the cursor to a pointer. The width and height are going to be 34 pixels both. Positioning will be absolute. And I'm going to define the offset from the bottom by 100 pixels and from the right by 12 pixels. Now I'm going to define the styles for assistant btn on when it's hovered. We switch the cursor to a pointer. We're going to give it a slight background fade. And border radius is going to be 360 pixels, which means it's just going to be a circle. Now we will define assistant-btn-inner for the inner elements of the div. Positioning will also be absolute. We're going to define offsets, top by 5 pixels and left by 5 pixels. Width and height are going to be 24 pixels. And now we need to attach the email assistant button to each composition form. So for const form of Gmail forms. Now before attaching the email assistant button, we want to make sure it's not attached already. So we say if form.parentNode to make sure we have a parent node if for some weird reason we don't, and form.parentNode.querySelector, and we want to select any element with the ID of email-assistant-button. So if that's null, we are going to attach assistant button to the form. So here we're checking if the form has a parent element, and if it does, we're checking if it already has the assistant button attached. If not, we attach it. Again, build a project, reload the extension, reload the page. Oh, it seems I made a mistake. I have a typo in my function name. Instead of A, I typed in E. Let me fix that real quick. Now I have to build the project again, reload the extension and the page. And there we go. We've successfully attached the email assistant button. Very nice. We've added the email assistant button to the email composition form successfully. Now we need to send a request to the completion API whenever the button is clicked. Since we're going to be calling the OpenAI API, we're going to install the OpenAI client library. npm I OpenAI. Now we need to instantiate the OpenAI client object, but before that we need to load the API key from the Chrome local storage. Since this storage API is asynchronous, we have to define a variable outside the callback function so that we can access it from outside. Const, and we use object destructuring, configuration, and OpenAI API is assigned, require OpenAI. Now let's declare the OpenAI client variable. Okay. Now we're going to load the API key from the Chrome local storage. chrome.storage.local.get, and we pass it an array with one string, OpenAI API key. Then we give it an arrow function and we use object destructuring to extract the object property. Const configuration is assigned new configuration, and we pass it an object argument. API key is assigned OpenAI API key, and after that we instantiate a new OpenAI API object with the configuration object and assign it to the OpenAI client variable. This is all right, but remember that we can change the API key at any moment. Luckily, the Chrome local storage API allows us to listen to storage change events. So every time something is updated in the Chrome local storage, we can get the new value. We do that by adding a listener for API key changes. chrome.storage.onChanged.addListener. We say changes goes to for let the array with key and value properties, but we're going to destructure the value property and extract the new value property of object.entries of changes. If key does not equal OpenAI API key, continue into the next iteration. Otherwise, OpenAI client is assigned a new OpenAI API object that contains the new API key value. Next, we need to handle the click event on our email assistant button. When the button is clicked, we want to send a request to the completion API. So we're going to expand our attach assistant button function. We're going to add a click event listener to the assistant button. Node.parentNode.querySelector with an ID email-assistant-button. .add event listener. We're going to listen for the click event and I'm going to pass it an asynchronous callback function. If OpenAI client is falsy, meaning if it's not initialized, we return. Otherwise, if OpenAI client is initialized, we say const completion is assigned await OpenAI client dot create completion. And here we provided an object with the request parameters. So we say model is assigned text DaVinci 3. The prompt is going to say continue writing the following email, new line, double quotes, concatenated with node.textContent, which is the existing content from the email form, concatenated with double quote. And I'm going to set the temperature to 0.6, which is just slightly above average. Once we get back the result, we say node.textContent plus equals a string containing a space, concatenated with completion.data.choices at index 0.text. So we're simply going to append the existing text content with the completion response that we receive. Let's test this out. Build the project. Reload the extension. Reload the page. Let's not forget to add an API key or this will not work. Okay, that's good. I'm going to type into the form, I have 2 cats and I. Then I'm going to click the email assistant button. And we got a completion. Isn't that amazing? If we click again, we get another completion. However, we are only getting a few words in our completions. To get more substantial completions, we need to increase the max tokens property in the request. So I'm just going to say max underscore tokens is assigned 1024. I've set it to 1024, which is just about average. Most models are limited to 20,048 maximum tokens, except for the newest models, which are limited to 4,096 tokens. Build the project. Reload the extension. Reload the page. Invoke the email assistant. And there we go. We got a very substantial completion this time. If you've used ChatGPT, you've noticed that the completions are streamed. So instead of returning the full completion inside one HTTP response, small chunks are returned using server-sent events. Server-sent events are similar to WebSockets, but they're not as powerful. If we take a look at the completion endpoint description, we can notice there is a parameter called stream, which can be set to true. If we do that, the server will send us messages containing small chunks of the completion, meaning they will be streamed to us as soon as they're generated. When dealing with server-sent events, we could use the built-in browser class event source. However, I couldn't get it to work with the OpenAI APIs because it doesn't allow setting headers and payload. To get around this, we will use a better implementation. SSE.js is a flexible event source replacement for JavaScript designed to consume server-sent event streams with more control and options compared to the standard event source. So let's install it. npm I sse.js at version 0.5.0. We're installing the version 0.5 because that's what the npm package page recommends. Let's import SSE. Import, and we use object destructuring to only import SSE from sse.js. Since we need to define the authorization header on the SSE request, we will need to capture the API key inside a variable. Let API key, and inside the callback of the Chrome local storage, API key is assigned OpenAI API key. Now we need to replace the OpenAI client call with the SSE call. I don't want to delete the existing code, so I will just comment it out. Const SSE is assigned new SSE. For the first argument, we provide the URL of the completions endpoint. The second argument is going to be the object containing configuration properties. I'm going to define the headers property and give it authorization, which will be bearer concatenated with the API key. The accept header is going to be a standard accept header that contains application JSON, text plain, and the ***. Content type is going to be application/JSON. The payload needs to be a string, so we're going to say json.stringify, create a new object, and I'm going to copy the properties from the previous object that we provided to the OpenAI client, paste that there, and we will set the additional property stream to true. And we define the HTTP method verb, which is going to be post. After we define the request, we need to add listeners for messages. SSE.addEventListener. We're going to listen to the message event, and I'm going to give it a callback res goes to if res.data is equals to done. We want to close the SSE connection and return. The string done surrounded by brackets is what's going to be returned by OpenAI APIs if it's the final message of the stream. Then we say node.textContent, and we append json.parse res.data because the response is going to be a string, so we need to turn it into a JSON object. .choices at index 0 .text. We need to add the event listener for errors, so sse.addEventListener for message error. Error goes to console.error, and we say completion action SSE error dash, and we provided the argument of error. Lastly, to send the request, we need to say sse.stream. So for this to work, we had to define the same request headers that the OpenAI client would set, but it's also necessary to set the HTTP method to post. Below that, we are adding an event listener for the messages that we will receive from the server. OpenAI will send a done message to indicate that it has no more messages to send for the given request. So if we get a done message, we can close the connection and return. Otherwise, we parse the JSON data from the response and append the completion text to the email form text. We also have an event handler for error messages, but there is not much we can do there, so we just print them out. Lastly, once everything is defined, we invoke the stream function, which will send the request to the completions API. Let's try this out. Build the project. Reload the extension. Reload the page. Invoke the email assistant. And look at that! The text is coming in as it's generated on the server. It's almost like ChatGPT. You are now ready to integrate OpenAI completions in your projects and create AI-powered applications. I hope you enjoyed the video, and if you wish to learn more, check out my course Complete OpenAI Integration at bestboss.com, with new courses coming soon. Thank you and take care. See you in the next video.